really the way to look at TopoDOT, it is the link between the acquisition of data, typically point cloud and point cloud project data, and all the intermediate steps for digital twin production. So I would say this: if you want to call topographies a digital twin, it certainly is, and that's a lot of our work. Transportation corridors typically is where we focus. Railroad. But then there's structures, bridges, everything across that corridor. I mean, that's our digital twin world. Mobile LiDAR and TopoDOT workflow and process, which we are very into process and exactly how it's done, quality control, all that. You get your digital twin better, faster, and cheaper. We've been very successful primarily in the Americas.
Hello and welcome to WGIC, the World Geospatial Industry Council. Our guest today is Ted Knack, President TopoDOT. Ted, thank you so much for taking time for this conversation.
Well, thank you for having me, Banu. Appreciate it very much.
All right. So let's get started understanding more about TopoDOT. Can you tell us about TopoDOT's point cloud processing solution?
Okay. Well, TopoDOT is a point cloud. So point cloud processing can mean many things. So what we really do, it's really the way to look at TopoDOT, it is the link between the acquisition of data, typically point cloud and point cloud project data, and all the intermediate steps for digital twin production. So it shouldn't be confused with processing point cloud that maybe just classify or maybe just or basically orients the data, registers the data, puts it in the right place in the world. We don't do that. We take that data and extract high quality digital twin production, digital twin models, analyses, other kind of information from that data, and basically extract the value from the data. We like to shortly say the things you get paid for. So that's where we fit in. That's where TopoDOT fits in.
Okay, I think we'll come to each of the aspects in detail during this conversation that you mentioned around digital twins. And in fact, the LiDAR data and the point cloud data that you talked about is getting increasingly important around the context of spatial digital twins, right? So you also mentioned about it. So how is TopoDOT supporting the spatial digital twin requirements of the clients?
Well, that's interesting. So we have it's a great question. We've been very successful primarily in the Americas. So that's we've started here. We're in Orlando, Florida, for those who don't know. And we started with a small group, like many kind of startups. And in another life, I was doing the acquisition side. I was president of Regal USA. So Regal is a well-known LiDAR manufacturer. Yeah. So, and we would just have trouble where people were collecting data, our customers were collecting data, and they were very upset. They couldn't get paid for any of the data. Nobody wanted it. We call them digital twins now, but they wanted topography. They want and we can go with that. They wanted a deliverable, a survey deliverable, let's call it that, which is really, digital twin in some sense. So we started to experiment and look into this area. We couldn't find any software that did it well. So I had a background in signal processing and signal image processing, and from another lifetime, and I won't go into my career, but before I started in LiDAR. And I said, no, nobody's doing it right. And I told people what to do. They wouldn't listen. So we developed TopoDOT. So TopoDOT is the digital twin. So how do we fit into digital twins? Well, I have some interesting thoughts on digital twins. I think we take a different approach. What TopoDOT does, but let's go specifically what TopoDOT does. We extract an engineering formatted quality point cloud, we extract from the point cloud an engineering quality vector diagram with the intelligence assigned to it, just as a surveyor would from the field. Our success throughout the Americas and now more in Europe and around the world is that we do that without exaggeration 10 to 20 times more productively than traditional softwares that were doing it before. We kind of left the pretend you're a surveyor going to each point and collecting and extracting from the point cloud to or some average or whatever they clicking on each point and assigning it information, which was the traditional workflow for a surveyor, right? And that's where the big guys got started. We said, no, how do we treat this as a signal and how do we extract things automatically? So we were very, very highly automated, but we allow the user to insert the intelligence in the model. So what does that mean? Engineers, they don't want a point cloud. They all think it's neat, but it's a 3D picture. Doesn't tell them anything and they can't feed their processes with it. We do primarily transportation corridors. We do all the mobile LiDAR in North America, pretty much. And what we do is they want to know where's the back of the curb, where's the edge of pavement. They only want a line. They don't want 10 million points. They see it when they look at it, but their computers don't know it's there. They need a line. And so we work in a CAD platform. On a CAD platform, we've developed TopoDOT. So we have all the level structure, the fundamental, we call it seed files, the fundamental classes of vectors and things that all, when we extract in TopoDOT, you're there. You have a vector, it's the right weight, it's the right color, it meets your requirement, whatever that happens to be, and they're always different. But that's all taken care of by our the CAD engine we use. And then TopoDOT extracts that automatically. So an engineer now has, this is the back of the curb. That's where the sidewalk meets. That's all he has to know. Doesn't want 20,000 points on the curb. He wants a line. So, and that's just the curb. I mean, sidewalk, cross sections of roads. And over the years, we've just developed more and more automated tools to find more details. We can, road surfaces, pavement condition. We can create service models that tell you that are very light and very flexible, but can tell you where there's a pothole and where there's going to be a puddle. That's maybe 10 millimeters deep. We'll find that for you. That's strong. That's very good. And that's useful. And basically the productivity is so high, our customers can actually exploit the productivity of their systems on the front end. And this had been a problem before TopoDOT came on the scene. It's one thing to have a mobile LiDAR system, which is really primary in what we work with, but we can work with any point cloud. But you can drive down the road at 40 miles an hour, 50, 60 kilometers an hour, 100 kilometers an hour, and you can take data. Well, that's productive, except if your office takes 3 months to get the project out, it's not very productive anymore. So we get that into very reasonable times, and by being 10 to 20 times more productive than competitive approaches to it. I won't even say they're bad softwares, it's just the way they work. We say, okay, you have enough throughput to pay because you get paid for deliverables, and the deliverables pay for your equipment. And then you utilize your equipment more and you maximize the utilization, which is very important. And then a lot of times surveyors don't look at the business plan as carefully as they should. They get excited about 1 million points a second and say, well, nobody pays you for 1 million points. I think it's from the former way of doing it where they were paid by the point. When you were a surveyor out and you got 1,000 points in a day, you did good. They paid you for that. That was some kind of, you could correlate your payment to that point because a surveyor was hitting each point, putting a name on it, going to the next point. Well, they're not in a 3D picture. We're just throwing points everywhere. No one knows what they are. So you have to now extract those vectors and lines and put the intelligence in the office. So that's what that's what TopoDOT is. We extract the intelligence from the point cloud in a way that's very, and the intelligent models, let's call them. And that's where we have our niche, and we've been very successful there.
I see that. Can you tell us some of the application areas of digital twins that you're seeing more in the market these days?
Sure. Well, okay. So I'm gonna. I don't. It's an interesting question. Look, I don't know, Vanna, have you ever looked up the definition of digital twin from the Glacier Consortium? It's a virtual representation of the physical world.
Yes.
Okay. Well, to be honest, I tell my surveyors, don't let the digital twin expression intimidate you. You've been doing it for 20 years. Every time when you did a survey and you made a line in the road, that's a digital twin. Because it also, in the modern definition or the application, it has to be synchronized in frequency and fidelity. Okay, well, that's where it lies. That's where because fidelity is how much you model. Well, you run into the practical applications is nobody really knows, there has to be requirements because nobody, you can't say model everything because nobody wants to pay for modeling everything. You never know when to stop. And, and some things are important, some things aren't. So it's really a collaboration between your requirements and what people need, your deliverable, and then what your extraction team and TopoDOT, what they have to pull out, and there has to be that communication. So I would say this: if you want to call topographies a digital twin, it certainly is, and that's a lot of our work. Transportation corridors typically is where we focus. Railroad, 3D structures, bridges, everything across that corridor. I mean, that's our digital twin world. And interestingly enough, it has that separation from buildings and the kind of digital twins that people are used to from structural, doing building design and things like that. And corridors are different, and people didn't realize that, which was an opening for our niche, really, for TopoDOT success, because the data in a building, in a room, is very dense. Your walls are 5 meters away, maybe 10. It's far, right? And your points are 1/4 millimeter apart, so you just have data everywhere, and it almost looks like a picture. And you can start clicking and measuring and extracting. When you go out into the organic, and I say organic world, so you have a transportation corridor, there's stuff, there's so many things you don't want. And then there's vegetation, and it's changing all the time. You don't have control of the environment like you do in a building. And so, what happens over 50 kilometers, of roadway is changing all the time in a city, right? So what gets modeled, what shouldn't get modeled, and you can't apply the tools the same way anymore. You can't just say, well, I'll just put a point every 1/4 millimeter and click here. You'll never get done scanning. So all the tools in TopoDOT is a completely different extraction method to produce the digital twin in topography than it was inside. So inside in a kind of a BIM road, BIM building, environment. And so that's where we noticed the difference. We early, when I was doing LiDAR acquisition, and I was in Regal, I realized I tried those softwares and I go, well, my points aren't 1/4 millimeter apart when I'm shooting something 20 meters away from an angle to a road. I'll never get it that dense. So I can't just depend on clicking the point I want. It's never there. And that's a problem. And then so you have to handle it very differently. And so that's where TopoDOT is very different in the way we extract these digital twins. So what are the roles? The roles are still the same. I mean, you still need a topography. The bottom line is now with mobile LiDAR and a TopoDOT workflow and process, which we are very into process and exactly how it's done, quality control, all that, you get your digital twin better, faster, and cheaper. That's what makes you successful in the end.
In terms of the kind of awareness levels, in terms of the acceptability, do you see a shift with this coining of the word and with technology transforming very rapidly and acceptance levels going high? Do you see that shift in the market, openness in the market?
Well, absolutely. Well, when we, so for us, again, I've heard the digital twin. The digital twin was coming out for a long time, and you know that expression, and as I looked into it, I said, okay, well, when you're starting a business like we were, we kind of we really focused on, okay, how are we going to make money next quarter and next year? So as far as where the future was going, I was like, no, I was worried. My time frame was shorter, which was a good thing because I started to realize it, as we just mentioned. Digital twin isn't anything different. They just want the same. If you're going to feed the process in the engineering, which is what we do, right? I mean, we're just a geospatial information is a stepping stone for actionable information, right? How do I design something unless I have to know what's there, and then how I tie into it, you know, all these things. So bottom line is I just said, okay, well, what we approached it to, look, I want to give you what you've got. I want to give our customers what they got and what they delivered for the last 20 years. I just want to do it more efficiently because now you acquire data more efficiently. So now we're going to extract it more efficiently. And when we crossed a threshold in productivity that we saw our customers all of a sudden have very, very significant financial success with their very expensive equipment, then our first customers were killing the competition, so to speak. Then other customers came to us and said, okay, well, now we have to do it your way. And everything we moved in. So I would say, I mean, I will make the bold comment, and it's not really, it's that North America is ahead in the process. And I would say in transportation corridors, for example, in Europe, we're finding, because we have offices there now, they're still in a stage where mobile LiDAR is sometimes the exception. You know, you use it in a particular instance, but there's still TopoDOT isn't as ubiquitous as it is here now, and it's still not a requirement. There's still some suspicion. It sometimes takes too long. It doesn't get, the extraction, depending how they're doing it. Whereas here, we've come so far and we dominate the market here so much that basically it is a requirement. You have to have mobile LiDAR to get a contract with in the Florida, in the transportation department. We have every state has a transportation department, and every state accepts mobile LiDAR now and said, this is the way you do it. There is no other way. We don't want people on the road. We don't want them down. We don't want them, and by the way, we get it for less money and it's better. So it checks all the boxes. So that's, again, so the digital twins, again, it's the same digital twin we always gave them, but it's just much more higher resolution, higher quality, but we focused on it being traceable back to the original control, the original geospatial reference points. We can trace the model, the point cloud, all the way back and say, we can guarantee this is correct. And we've been and that's the other aspect of TopoDOT, where we've looked at those issues where, anyway, so that's where, so as far as we're digital twins, it's better, faster, cheaper. It's the same Carter, but instead of like 30-meter cross sections, it can be 2-meter cross sections or 1-meter cross section. Well, people are starting to realize that the engineers are starting to realize we make less mistakes now. We don't find that we had to fill in and found something missing between that 50-meter cross section when guys were doing it on the road, right? Now, we have all this higher resolution data, and that leads to less uncertainty in the design process. And when there's less uncertainty in design and the construction process and the engineering process, all of a sudden you see the real savings. You see less change orders, less uncertainty in the quantities moved. There's all kinds of information you can feed to the engineering process. Or I'd say the construction process, where the real money is, by the way. that's where all the money's spent in construction. So we're kind of focused on that in TopoDOT, and we're changing the world a little bit in our own little way. So it's nice. The hardest part is when we started, the hardest part was to change everybody's process. That took a long time, relatively 5-6 years before, okay, this is the way to do it. And now we're changing the process again. And that's some other cuts. We're looking at the data management, the data governance, and how to do that effectively. And basically how to collaborate with all your engineering, your construction, your design in a very efficient, low cost way that can be scaled. And we have a TopoShare product that's doing that. And we do it, again, very differently than everybody else. So we focus on those things. I think, so it's a long answer. I'm good at long answers. I'm sorry.
On that count, I would like to ask you to elaborate a bit on your data governance solution, because that's where I think the productivity aspects, the savings aspects come along. Isn't
Well,
it?
absolutely. Yeah. We do it a little differently. We don't offer a service which many of the companies are doing. Say, store your data here, we'll stream, let you look at it, bring it down. I always have a way of basically saying, okay, well, what are they doing? And I don't want to get in, we dominate the feature extraction part of the process, and we do that better than anybody else. But now there's a lot of companies that have just sprung up saying, okay, well, I'm going to store your data for you. You probably know many of them. We don't have to mention their names here, but the bottom line is I looked at how they were doing it, and our customers were asking us if we had a solution, and we'd say, no, I don't. Store your data where you have to, bring it down in open format, and TopoDOT will extract. I said, I just haven't looked at that, and that was years ago. And then they came back and were telling me what's out there is not financially viable. It's too expensive. When you start scaling, the numbers go crazy because there's a lot of streaming involved, a lot of IT. People don't realize when you put data on a server and say, you're going to go to a server, you're going to fence it. You're not just storing data and transferring it. You're opening up many microprocessors, threaded typically, and RAM. Your pennies of cost for storage and transfer go to dollars or whatever your currency is, but they go to dollars very quickly. And if you can look at it's very transparent. You look at some of the costs, it's the traditional ways and how everybody's doing it. So we saw that as an opportunity. And so we developed TopoShare, and what we do, TopoShare is just a tool. And we say, okay, we let you organize your data inside of TopoDOT. And that was a process we learned a long time ago. I mean, how do you get 100 kilometers of data into your project? Well, you have to divide it up, chunk it up, take it in at certain times, and you have to organize it effectively so you can get to it very quickly. We had that covered. We've been doing that for years. We say, well, okay, let's take those after you've tiled, is the word, right? You tile your data in some intelligent way. We do it very automated, and it works really well. Well, let's use those, and that's what we put up. And we'll give you a tool to put it on your data, your storage medium. Let's call Amazon Azure the big ones, right? Okay. And then your costs are just what it costs to store it and transfer. And we just give you access from wherever you want. So you can just say, click. Basically, the way TopoShare works is that I can sit with my laptop. Now, our customers that are using TopoShare very effectively, they may have over 1,000 projects now. They've been doing it for years. It's proven, and they just say, okay, someone can go for their laptop, click, look at a map, see all their data on a map, say just points, and open up a project. Tiles come up in a URL, and they can just look at it, Google Map, and over Google Map, and they can go, okay, I need this tile, this tile, this tile, data transfer down. Once it's cached, I don't care how long it takes. There's no streaming. Streaming is expensive. We just transfer data, 7 cents a gig. It's not bad, $1 or $2 for a mile or 2 kilometers. It's not bad. And then you have it cached on your hard drive. Next time it comes up real fast. So when you have, because in the TopoDOT process, you still have, and it's always going to be this way, you collect data so quickly, you have a team. You don't have one person extracting. You'll never get finished either, even with TopoDOT. If he gets 20 miles in a day or 30, 40 kilometers, that guy can't get it out by himself. So you have 5, 6 working in parallel. Well, how do they all get to the data? How do they all get to when they need it, where they need it? It's very elegant and simple. Just everybody looks at the same map. They click the ones they need, download it, their desktop. We don't care how much, they don't have to do anything special. When their data fills up and they're done their project, they delete it because it's still up there. You just pull. Only administrator gets to push it up. So we have this administration process where, you know, you can have complete control of your data, you can organize it, and it's totally file-based as far as data storage and transfer. That's the real difference. And we give you a tool. We don't charge for that. We don't charge. It's part of TopoDOT is the data governance. And the other side of the data governance is that, I'll reiterate, I mentioned a little bit. In the process, we offer all tools for quality control. Don't underestimate how still it's a problem, even in the States, for people that aren't using TopoDOT or hadn't been trained. Sometimes they have it and they don't use it correctly. They go, look, they get data, they send it down to somebody, they start extracting and realize it's off by 10 centimeters. That's all day long, you know. You have to go through a process where in our process, the geospatial team is put at the center of the process. And they assure that whatever somebody wants to do, whoever contacts them through our TopoShare connections to engineering, construction, whatever, who wants that digital twin, because there's no 2 digital twins that are alike. That's the other fallacy of digital twin. There is no one truth model. And only God did that. Everything else is like whatever we do. All models are wrong. Some are useful. Stick with that, and you'll do better. Because so that says, what do I need for that model? What's the objective of the digital twin? What's it supposed to do? How accurate does it have to be? And will the data, the geospatial administrator has to say, where will that data support that digital twin? Because maybe it won't. Maybe it wasn't controlled. People are driving down mobile LiDAR. They don't have control, so it's drifting around. That's not appreciated so much at times. And then it's misaligned between overlapping areas, and that's an issue. So we assess all that very rapidly, and we can say, all right, this data will meet or it won't. And then Geospatial Administrator says, here's what has to be done to meet your objectives. Now, that's another long answer, but I hope people understand that it's a very effective and low-cost way of organizing and storing your data. It's the lowest cost way possible. There's no way you could do it less expensively because we don't add any cost. It's just your storage and transfer costs that you can look them up on Amazon or Azure. We don't care. And then basically is that quality control. That's another really important aspect. That's data governance. It's not just where your data is. It's also, is it quality? Will it meet the requirements of your objectives? And that's missing too from everybody's thought process in data governance. So we've cracked that. We've been doing about 2 years of beta testing because we're not a marketing powerhouse, so it would be wider. But the guys that are using it, I'd say 15 or so, are doing really well. And so we know it works, and we're rolling that out now too. So we're always trying to change the way people think a little bit in good ways. And we try to make them successful. So we always pay attention to their business model and say, do we fit in? Do we help? We don't want to just be a cost that you have to bear. We want you to be happy. So
well,
anyway.
Thank you so much for that elaboration, Ted. That brings me to the second part of this conversation, that is your association with WGIC. You are one of the newest members of WGIC. Thank you and welcome on board. I would like to understand what brings you to WGIC and how do you see the business aspirations aligning with that of WGIC?
Okay. So I think everyone is looking at, it all starts with point clouds and the acquisition of, and we're in a space that's transportation corridors. It's called civil. So
Yes.
it's not the only space, but that's where we kind of have our main interest. And obviously there's different takes on everything. There's S3s out there doing things. Let's just talk GIS and the like. So what, and so they're a big one, right? And everybody knows them, but there's many others and all the manufacturers. So, I mean, there is an aspect that I'd like to know what everybody's doing, what their thoughts are, and I'd like to share my thoughts, because I really don't approach it in an overall competitive sense. I really like to share with this is what works, I mean, we have proprietary things that we do, but it's not that doesn't enter into these conversations. I really want to say, and I don't mind, because I don't see that we compete with anything really, any viewers or anything like that. And quote your, we like to get out of TopoDOT as quickly as possible and get you to where your data wants to live, whether it's CAD or whether it's GIS environment or whether it's, I'll just extract what you need, get there, make your money, deliver it, use it. So we're in this middleman, how do you get your digital twin produced? And so I want to understand the data formats, it's more than data formats and things. Actually, it's really, I think we have something to offer in our conceptual approach to how we're attacking it that'll make the market grow. And I think, I hear from our customers that are approached by many solutions, and they get confused. And I've been on standards committees before. Not always my favorite thing. It's you can spend a lot of time, and you really just want to. Sometimes you just want to like blow your brains out. It's just too long. It's like I'm too impatient. But there is a place for understanding and really sharing a common look of work, common things of concepts that work. And I don't mind if other companies do that same thing. That only makes it grow. And then sometimes, so we'll contribute where we think we can. We'll learn from people that are having, that have other interesting aspects. I think the other thing that's happening too is this, they call it data fusion, but you've heard these expressions, right? Our customers are all they typically work with 5 or 6 sensor platforms to do a corridor now. Somebody might, run down mobile LiDAR, then they have something on their back and walk along that, and they have, there's all kinds of fusion. It all comes together, and now there's satellite. It's all coming together in an environment. So that's really another aspect. I think it's really with WGIC is really the data committee that we're on. How does that all play? How does all our data play together effectively? Because we can't have all these separate channels. These separate data to delivery channels just crossing all over each other. That bypasses and doesn't get the synergy between the data sources, right? But then again, once you combine data sources from different things, it gets kind of complicated quickly, So these are things that we've had experience with and we've been successful. So we think we can contribute and we can learn from other people too in that committee.
Fantastic. On that count, your expertise and your background working on the data will really add value to the data committee that you have recently joined.
Yes. Well, we hope so.
Thank you so much, Ted. Thank you for giving this opportunity to talk to you, and I appreciate all your perspectives and thoughts.
Okay. Well, thank you, Anna. It's nice meeting you, and I hope we talk again sometime.
Sure. Thank you so much. Bye-bye.